see, physics, mechanics, and lecture 4. So you can kind of see the name there, resolving. Do you know this word, resolving? Resolving vectors? Good guess. It doesn't actually have to do with solving, believe it or not. Okay, so you can write that down. Resolving vectors is what we're going to be doing now. So I need to fix the date. Okay. You got that, yeah? Okay, so you've done this word in maths, perpendicular, haven't you? Yeah, so you know perpendicular. So that will be an important word now for us. Okay, these words, horizontal and vertical, you know these words? Yeah. You knew them already?
Yeah.
Yeah. What's your IELTS score actually?
I haven't done my IELTS.
Okay. What do you think you are?
I have no idea.
You no idea.
I speak English at home and like everywhere else. So
Okay. So it's no English is not going to be a problem then. Okay. Horizontal and vertical vectors can be added together just like any two vectors. And this is actually a common problem in mechanics. So what we really want to be looking at today is the opposite. So after you add two vectors together, can we go backwards? Can we do the reverse? That is, taking a vector and writing it as a sum of a horizontal and a vertical vector. So just as actually a picture, to make it clear what I'm saying. So here's a horizontal vector. I'll draw that again. Here's a horizontal vector. Here's a vertical vector. And using the vector triangle we did last time, this is the resultant vector. So what we, oh no, that's not what I wanted to do. So what we want to do today is, if I give you the resultant vector, can we go backwards? Can we find what this vector is? And can we find what this vector is? Okay, so to help us do that, we need to use our friend Pythagoras. So you all, well, I think everybody knows this from middle school, but in case you didn't know the name of it, it's Pythagoras. So whenever I say we use Pythagoras, it means using this rule. But everybody knows this rule. Everybody knows this rule. Okay. So what's useful with Pythagoras is Pythagoras can help you to calculate the magnitude or the length of the resultant vector if you know the magnitude of the other vectors. So this is why Pythagoras is useful. So for example, what is the magnitude of the resultant of 3 meters east and 4 meters north?
5 meters northeast.
Yeah, now it wouldn't quite be exactly northeast though, but it'd be northeasterly.
Yeah.
So what did I say? 3 meters to the east, was it? 4 meters to the north. So the resultant is here, and we'll say that's x meters. And you know x squared equals 3 squared plus 4 squared. So x squared equals 25. So x equals 5 meters. And it's not quite northeasterly because it's not quite 45. But you're right, it's roughly northeasterly. So that's nothing major. But a little bit of vocabulary now. You've seen these words before in high school? Yeah. So opposite is the side which is opposite the angle, of course. Adjacent is the side which is touching the angle. And hypotenuse is the side which is longest. Or, as some people say, the side which is opposite the 90 is the hypotenuse. Do you need to write these down, or no? They're okay. You know this, all right. So the reason I'm talking about this is because we can use a function on our calculator to calculate the angle. Now we haven't done this in maths class, but we will do it in maths class later this semester. But for physics and for now, we can just say we can do it on our calculator. So if we tell our calculator the opposite, and if we tell our calculator the adjacent, it can tell us the angle by using this function on the calculator, tan inverse the opposite divided by the adjacent. And you probably have seen this before, but we'll do it in maths class. So that is the theta. So we go back to the example I was doing. Do you have your calculator with you?
Yeah.
Let's calculate the direction. Let's calculate the angle. Yeah, so theta is, and its second function, or shift, tan inverse 4 over 3. Just like the close bracket. If you just press delete.
Okay. Alright.
Yeah, that's it. So what did you get? Press equals then.
53.13.
Okay, so 53.1 degrees.
Yeah.
So that's the direction. Yeah, that's okay?
Yeah.
Yep, alright. So let's go back here. Do you need to write it down, or maybe do you want to write this one down?
So
Yeah.
can I just like look at it first? Yeah, okay. But
Yeah.
we don't have to write like the inverse thing, right? It's just
Oh no, you do need to write this, yeah.
right, let me just write something.
Yeah, take your time.
So you wanna find the angle, right? The right one?
Yeah.
Oh yeah, I understand now.
It's okay for you? Yeah.
Okay.
Yeah, we'll continue?
Yeah.
Yeah? Okay. Right, so I don't know, different countries are going to have different ways to remember these rules. Again, we're talking about this in maths, but we have these relationships between the sides and these functions on our calculator.
Yeah, I remember it as well.
Sokotoa, yeah. For example, if this was, I don't know, like if this was 3 and this was 4, then we can say that the sine of theta would be, let's see, 4 over 5. And the cos of theta would be 3 over 5. And the tan of theta would be 4 over 3. But anyways, the reason I'm showing you these rules, which you said you've seen already, is that these can be useful to find the opposite and the adjacent, the horizontal and the vertical. So if we know the magnitude and if we know the angle, then we can find the opposite and the adjacent. So basically we want to know the magnitude of the opposite and the adjacent. So how can we do that using these rules? Well, by using sine, cosine and tangent. So let's see how. Okay, so we have our vector and we only know 2 things about the vector. We know its magnitude, which I'll call or. Now, it's kind of hard for me to draw this, but actually I should have made this clearer last time. If I write or in bold, that's a vector. And then if I write or like this, that's the scalar for the vector. So like for example, this is vector x. But if vector x is 2 meters long, then the scalar x equals 2. Now that's not clear. I don't want to give you too much.
But what's the difference in what is the difference between the scalar and vector again?
The one vector is the one with the direction.
Okay.
So like for example here, this is vector x, which
so
is 2 meters northeast, and then scalar x would just be 2.
It's
Yeah.
not meter?
Yeah, 2 meters, yeah. Now that's not great.
That's okay, I understand.
Yeah, now we see, I don't want to give you too many symbols, but some people, to make it clearer, they put an arrow for vector and then no arrow for scalar.
That's what we do as well.
Yeah, and some people, to make it clear, put this to mean magnitude.
Oh, I don't do that.
Yeah, so anyways, where was I? Back here. So this is vector or, and its magnitude is or, and its angle is theta. So what I'll do is I'll draw in the triangle, and this side is the opposite and this side is the adjacent. And you know that sine theta equals the opposite over the hypotenuse.
Yes.
Therefore, the opposite is equal to or multiply sine theta. Likewise, our formula says cos theta is equal to the adjacent over the hypotenuse. So therefore, the adjacent is equal to or cos theta. So that basically gives us our result, that if you have a vector and its magnitude is or and its angle is theta, this side here will be equal to or multiply cos theta, and this side here, the vertical, will be magnitude will be or sine theta. And the way I tell students to remember this is the or sine is the one which is opposite, and the or cos is the one that touches.
Can I write this down?
Now, which one? Do you want to write this or both? Yeah, well, why not write both?
I mean, like, actually, I can figure it out, but
You want the result?
yeah, this one there.
Yeah. So remember, the sine side is opposite the theta. And the cosine side touches the theta. Oh, my pen stopped. Why did it stop working now? The heck? You don't happen to have a spare USB cable. I don't know why this has stopped. I don't know if it's the cable or if it's the laptop.
No idea. I've never even seen that device before.
Ah, no, but like to charge up your phone,
Oh.
is it not the same?
I think it is the same.
What's happened now? Is it the same?
So
Your cable doesn't look like it's in good shape either.
I actually looked for a new one, but it was out of stock, so I had
You have to.
to innovate.
Yes, indeed. Let's see if this one will. Oh my goodness. If
But
this one.
it works though. It still works.
No. I don't know. Maybe. Okay, I'll try and fix it in a moment. But anyways, you're writing this down. this. I got it back. All right, so technical difficulties. Cosine is the side touching the theta. Yeah? Okay. Right, so, yeah, speed is actually the magnitude of the velocity vector. Did you know that already?
Yeah.
Or, yeah, so but that kind of makes sense. So like for example, if I go back up here, oh, where's it gone? Where's my example I was doing? Yeah, over here. So if I was just to change this one I was doodling earlier, if it was x was 2 meters per second northeast, that's the velocity. The speed is 2 meters per second. So speed is the magnitude of the velocity vector. Okay, let's have a look here at an example. So we have this vector which is 10 horizontal and 20 vertical. What is the magnitude of this vector? So let's see what we get for this. 10 horizontal and 20 vertical. Okay. So the vector is 10 meters per second this way, and 20, this is what I said, wasn't it? 20 meters per second this way. Okay, so the magnitude, let's call the vector x. So the magnitude of x, yeah, it'd be square root 10 squared plus 20 squared. So that's square root 500, which, I don't know, what's that as a decimal? Maybe like 21, 22?
22.36.
Okay. Now, the theta is tan inverse 20 over 10, which is tan inverse 2, which is
63.4.
okay. That's not so difficult. I think there's another example. Do you want to write that one down?
No,
it's okay? Alright, so this one here is a ship is sailing 15 kilometers an hour north at a bearing of 30 degrees. I shouldn't really say north if I gave a bearing. A ship is sailing 15 kilometers at a bearing of 30 degrees. How fast is it travelling to the east and to the north? Okay, so the ship is going like this. I'll draw it for you. Yeah, so here is 30 degrees and here is, the magnitude is 15 kilometers per hour. And we would like, we would like the horizontal, the easterly, and the northerly. Or if you want, you can draw your vectors. It's both are the same. You can draw it this way if you like, northerly and easterly. Okay, so we have to use our other formula. We know that this is 15, which is great. So one of these will be 15 cos 30 and one of them will be 15 sine 30. Which one do you think this will be?
The sine would be that one.
Yeah, so this side is going to be 15 sine 30 and this side will be 15 cos 30. So if you can hit in on your calculator 15 sine 30, let's see what we get. 7.5 kilometers per hour. And then the other one?
Are you supposed to write the direction as well?
What do you mean?
Like for
Oh, here?
Yeah.
I will when I get the answer in a moment.
It is 12.99, which is 13.
13 kilometers per hour. Yeah?
Mm-hmm.
So the answer is, the vector is 7.5 kilometers per hour to the east and 13 kilometers per hour to the north.
Okay. Can I write down the question?
Oh yes. I shouldn't have that word north in there. Okay.
Yeah.
You got it? Yeah. All right. And you want the answer as well? Yeah.
I just want to ask you something.
Yeah.
Like in maths, we learn that if like the point is in the middle, it's like elevated a little bit. It's a decimal, right? And if it's at the bottom, it's multiplied.
Multiplication. Yeah.
But then in Malaysia, it's the opposite.
Oh no.
So as in Korea and many other Asian countries.
Really?
So, yeah. So
I'm trying to think now. It's kind of weird. A lot of maths books here use the dot down below for both multiply and decimal, which really annoys me. But it really should be, the middle is decimal and the bottom is multiply. Sometimes people use the middle for multiply, but they usually at least put a circle around it to make it different.
okay. So but I'll just write it in the middle then, and bottom for multiply.
Yeah, and then of course in France they don't even use a dot;
Oh.
they use a comma.
Oh.
So then this is 1.5 in France.
Okay.
That's weird, huh?
Yeah.
So this in France is not 1,512; it's 1.512. So what do you think they do when they want to write 1 million?
Yeah, just like space, is it?
Nope, gets
Oh,
dots. So yeah, it's funny, you don't think about it until you see someone doing it differently. Yeah. And now this is the reason why that nowadays people are told you should use spaces, because Some countries will use one thing and some will use another thing, you know.
Mm.
So I'll try to use spaces. This is the proper way to do it. Okay, do you have this? We can continue? Yeah. Okay. So what's left now is the questions for you to try. Let's see, how much you got? Got about 5 minutes, 5 or 6 minutes. These questions aren't too long, so actually you might be able to get them done now.
I need to copy them down, and it's quite long. So
Well, if you want,
it's on the
you have them on Moodle. Do you want to open Moodle on your phone?
on my laptop.
That's fine. Yeah. Just make sure they're there.